Hope you're having a nice evening / morning whenever you're doing this. So here are some vocabulary that I would like you to have in your notes. And you can pause this video and write them down. But just remember that the response variable measures the outcome. In the past, you would have referred to this as your Y versus the explanatory in the past would be your X. So it explains or helps predict the changes. So what is causing the response to happen? And sometimes we don't know all the different possibilities, and we'll get into that later on as we continue to look at the different stuff that we'll be learning this year. A scatter plot is just data plotted, usually on a Cartesian plane, usually only in the first quadrant, showing the relationship between two variables. So when we plot one on the X and one on the Y, we can see how they're related. Direction, just think if you were to draw a line, what kind of slope does it have? What is the pattern? Form tells you, is this going to be a curve? Is it going to stay straight? Is it more linear? Strength is how closely are the data points plotted. So the closer they are to being linear versus more spread out, that's how we can determine the strength. Outliers are just going to be data points that fall outside the overall pattern. And these are going to be data points, and sorry for bringing up the extrapolation earlier, that's actually going to be in 3.2, and I just thought y'all had already read that. Positive association is the explanatory variable, or as X increases, the response variable increases. So just think back to positive slope, as X increases, Y increases. Negative association is the explanatory variable increases, the response variable decreases. Your correlation is your R, and it measures the direction and strength of a linear relationship between two variables. And we can say that the absolute value of R is less than or equal to 1, meaning it's going to fall somewhere between -1 if it's a completely perfect negative slope, and +1 if it's a perfect positive slope, and 0 would mean that it doesn't have a relationship. So when it gets less than, if it's in between -0.5 and +0.5, you're looking at this gray area where there's not a strong relationship there. A regression line is just that predicted line that goes through the most points or in between the most. Your predicted value, or Y hat as we say, is the point predicted at a certain value of X. So when we look at the bungee jump, we'll be comparing a predicted value to the actual value. And then interpolation, I went ahead and included this. This is not something in the book, but it's something that you should just know in general. It's a predicted point within the given data. If you need to pause it, then feel free to do so. Alright, so here is some data, and here's how we would kind of look at it. And you want to look at your two variables. So we have the total bill and the tip. So it has two different things plotted on here, and you can kind of notice a few things from the get-go. It looks like dinners are the more expensive in general, and also the higher tips as we look at kind of the upper portion. More people, it looks like, tip more for dinner. So our explanatory variable would be the total bill, and that helps predict our response variable, which is the tip. And we would hope that as people's bill increases, that they would tip more, because people are taught to tip a certain percentage. But that's how we can tell that this explanatory variable gives us the response variable. Now my direction, I can see that it's going up and to the right, so as the total bill increases, in general, we are seeing the tip increase. So our direction would be a positive association up to the right. We have a few unusual characteristics. You can see that this person, they paid about $8, but tipped about $5.50. So that's a large tip. We also see down here that this person, their bill was probably, if this is 35, that'd be about 32 or so, 33, and they only tipped about $1. So unusual characteristics, these would be your outliers. And if you want to think about when I'm describing a scatter plot, I'm going to look for the deaths, okay? So we have an outlier at 550 and also one at 32.1. Later on, we're going to look at how do we actually determine which points are outliers, because you can see that we have several other points that are kind of outside the general data, but right now I just picked the two strongest outliers. The form is very linear. We're going to pause this for a moment. Sorry about that. We are back. So the form in general is linear. There's not like a curve that we notice that as people are getting paid more, they seem to be tipping, or their bill is more, they don't seem to be tipping more and more. It seems fairly linear. And then the strength is not very strong, so this would fall into the somewhat weak category. But on an AP test, we would put these more into sentence form. I just wanted you to get an idea of how that looks all together. Alright, and I did want to show you how to put this in your calculator. So this was the back example from today's lesson, and this is the amount of sugar versus the amount of calories in here, and we can see kind of some of them seem to be just multiples of 10, and then others, they have less than that. So like Raisinets have healthier sugars, and so that might have something to do with it. But what I've done is I have gone into the calculator, and you'd go from the home screen. You can click to add a spreadsheet. I've already put in the data, so you don't have to watch me do so. But you can see that as it goes down here, we can have all of our data points, and you can add X's and Y's if you would like to the top, but for our purposes we don't need them. So you would go, once you get all your data, all your X and your Y, we'd go in and we'd go to Menu, and we're in Statistics, so that makes it helpful, Stat Calculations, and we will be using this linear regression form in statistics this year. And so it's a little different than what you might have been used to, because now our slope is the b versus the y-intercept. So it's switched up a little bit. But our x variable list is going to be in the y column, so I'm just going to come in and make this is in the a column, not the y column, sorry. And then we have the y list is in the b column. And so I'll just put both of these here. And we can hit OK, and we now see that it gives us an A value and a B value if we wanted to come up with a regression line. And if we scroll down, we can see that the R value is 0.618, meaning it's not a super strong, it's greater than 0.5, and so there is some strength to that correlation, but it is not strong enough to be like this is super linear. And so I was going to show you, I went ahead and plotted it on the graph just so you can see, and we'll go through these steps some more until y'all get the hang of it. But if I go back over here, you can see that this is what the graph looks like, and so you can see maybe if I took out this point right here, it might be a little bit more linear and we might see a change in the correlation coefficient. But hopefully you get all this down and we can look at whether or not we can safely bungee jump tomorrow. All right, y'all have a great evening or day, and we'll see you. Bye-bye.